Hello everyone, I welcome you all to Startup Academy, India's exclusive coaching for ISS examination. In the previous lecture, we did moment generative function, which is MGF. In today's lecture, we'll move forward to a new topic, which is characteristic function. Now, characteristic function is very much similar to moment generating function, but the only difference between them is their formula, and that characteristic function exists for all random variable, whereas moment generating function might or might not exist. So characteristic function is denoted by phi x of t, where x is the variable, and it is given by expectation of e raised to the power I t x, which also can be written as integration minus infinity to infinity e raised to the power I t x fx dx, when x is a continuous variable, and it is also denoted by summation over x e raised to the power I t x px, where px is the pmf of x, where x is nothing but a discrete random variable. So these are the formulas and how we calculate characteristic function of a random variable, where I is nothing but an imaginary number which is denoted by minus under root of minus 1. This is I. The only difference between characteristic function and MGF was denoted by mxt and has the formula expectation of e raised to the power tx. There was absence of I over there, which is the imaginary part. Now moving forward to some of the properties of characteristic function. It has same properties as that of MGF, where characteristic function cxt can also be written as characteristic function of x with ct, where c is nothing but a constant. It is again not independent of change of origin and scale. It depends on change of origin and scale. This is one property. Then there comes another property where we can calculate our moments by mu r is nothing but summation over r goes from 1 to infinity mu r dash into a characteristic function upon r factorial phi x t. This is our characteristic function. This is how we calculate characteristic function when we have to calculate the moment generating function of rth order. Now there are some necessary condition for calculate for a function to be a characteristic function. The necessary conditions are three, which states that first condition is that characteristic function at t equals to 0 should always be equal to 1. Then the second necessary condition is characteristic function should always be less than or equal to 1. And the third necessary condition is the conjugate, that is characteristic function of minus t, should be equal to the characteristic function conjugate. Now what is the conjugate? If we have done the imaginary topic, then if an imaginary number can be represented by a plus ib, where I is imaginary term, then the conjugate of this can be a minus ib. This is the conjugate. So this tells us that the third property is when the t is taken as negative, then it should be equal to the conjugate of the characteristic function. You can put x. We are talking about the variable x here. So these are some of the properties that will be required to solve your questions. Now let us move to our questions for today. this has been given to us, this question. It states that which of the following is not a characteristic function. So we know that we have done three properties. That first, the characteristic function should be when t is equals to 0, it should be equal to 1. Second is when the characteristic function is taken at t, it should be less than equals to 1. And the third property is the conjugate of a characteristic function should be equal to characteristic function when t is taken as minus t. So let us consider the first one. So first a part has been given to us. If we take t equals to 0 in this term, 3 by 10 e raised to the power 0 plus 1 into e raised to the power 5 into e raised to the power 0 minus 1 into e raised to the power 5 into 0 minus 0. So this will be e raised to the power 0 and this will also be 1 minus 1 e raised to the power 0. So both of them becomes 1 and here also e raised to the power 0 becomes 1. So this can also be diminished. 1 divided by 1 plus 3 by 10 will give us 13 by 10, which is not equals to 1. So our first option is only the answer, that this is not a characteristic function. Let us check rest others also. If we take cos bt and if we take t 0, then it will be cos 0 and cos 0 is 1. Then let us take the third function that they have provided us, e raised to the power it. If we take t equals to 0, then it will be e raised to the power 0 and anything raised to the power 0 is nothing but 1. Then we take the fourth one where it is given as 1 plus t square. If we take t 0 here, then it will be 1 upon 1 plus 0, which is 1 only. Then all of the others are coming 1 except for the first one, which is our answer. This is how we check whether a given function is a characteristic function or not. Now moving forward to another question similar to the first kind. They have asked us that whether the three of them are characteristic function or not. So if we say, let us talk about the first function, which is 1 minus it. If we take t equals to 0, then phi x 0 is coming as 1. If we take t equals to 0, 1 minus 0 will be 1. And the second property, let us check the second property as well. If we take it phi x t, then it will be nothing but 1 minus modulus of phi x t, which is nothing but under root of a square plus b square, 1 plus minus 1 and t square. It will be plus t square. But this condition, whatever value we put for t, either if it is negative or it is positive, it will always be greater than 1. So this does not imply that modulus of phi xt is less than equal to 1, which does not imply that, and hence this first one is not a characteristic function. Now let us check for, we don't have to check for the third condition because it is not a characteristic function. The second function given us is phi t is equals to e raised to the power I at. Now if we take it as phi x 0, it will be 1 only, e raised to the power 0 is 1. If we take it as modulus of phi xt, which will be e raised to the power I at, can be taken as under root of sine square t plus I cos square t, which is 1, which is equal to 1, and hence satisfies the condition less than or equal to 1. Second condition is also satisfied. Now if we take it phi x minus t, it will be e raised to the power minus I at, and if we take the conjugate of phi xt, then it will be also be, if we change the sign of I, it will also be e raised to the power minus at, and both of them becomes equal, so it satisfies all the three conditions, and hence second one is a characteristic function. Now if we talk about the third function, which is phi xt equals to 1 upon 1 minus t. If we take t as 0, then it will be 1 upon 1 minus 0, which is 1. First condition is satisfied. Then if we take modulus of this, then it will be 1 upon 1 minus t whole square, which will be nothing but which can come less than or equal to 1 if we put the values of t. Now if the third condition here, if we take it, let us take it here. If we take phi minus t, then it will be 1 upon 1 plus t. But if we take it a conjugate of phi t, then it will be 1 upon 1 minus t only, because there is no I present, so we cannot change the sign of i's. So it will be 1 minus t only, and hence these two are not equal, which says that this is also not a characteristic function. So only the second one is a characteristic function, the first two are not characteristic functions. They can ask you this much harder question as well, and they can ask you this much easier question as well, where you have to check just the first property, and then it differentiates itself from the rest of the other options. Moving forward to the next question. Here they have asked us to find the characteristic function of x with the PDF. Now we know that the characteristic function of any term is nothing of a PDF of a continuous random variable is from minus infinity to infinity fx e raised to the power itx dx. Now if we consider this, then the first is from minus infinity to 0, 0 dx, plus 0 to 1 e raised to the power itx, fx is 1, so it will be multiplied by 1 plus dx. And the last one is from 1 to infinity, 0 dx. So these two terms, first and the last term, will be 0, and we have to calculate for this only. So if we integrate e raised to the power itx, it will be e raised to the power itx upon it with the limit 0 and 1, the limits of x. If we put the limit of x, it will be e raised to the power it into 1 minus e raised to the power it into 0 will be 0, which makes it nothing but equal to 1, and upon it, which matches our option number B. This was a simple and direct implementation of the formula for the question. Now moving forward to our last question, which is also a PYQ, and here we don't have to calculate anything. They have just asked the property of a characteristic function. While telling you about characteristic function, I told you previously only the only difference between a characteristic function and a moment generating function is it always exists, but the moment generating function may or may not exist. So they have asked us what are the following, which of the above statements are correct. So first of all, let us see, it always exists, which is true. They have asked about characteristic function. It always exists, that is true. It is uniformly continuous on R. Yes, characteristic function is always uniformly continuous on R. So our second statement is also true. It is independent of change of origin and scale. I only told you that it is not independent of change of origin and scale. It depends on it, as well as NGF also depends on it. So third statement will be false. We can say 1 and 2 are true and third is false. So there is option like this, and there is option like there is nothing option where 1 and 2 are true and 4 also occurs. 1, 2, either this can be our option or this can be our option, but rest 3 doesn't have this option. So our option B will be correct. We don't have to even see fourth, but let us check it as well. If the characteristic function of a sum of random variable is same as the product of their individual characteristic function, then the variables are independent. No, that is only true for a MGF, where we state that if they can be independently represented as this, then x and y are I identical, not independent, right? And similar goes for the characteristic function. If we say that these are the characteristic function, then we can represent it by this only when x and y are identical and not independent. They have given us independent, which is also false. So statement 3 and 4 are false, and this makes our option number B as correct answer. So this was just on properties. As you read it, you will be thorough with the concept. This was all for today's lecture. I hope that I was able to make you understand characteristic function. You can solve as many questions on the same on the same topic. And if you face any doubt, then you can ask us on our WhatsApp channel. Only relevant doubts will be answered. All the best. Thank you.
Startup Academy presents Lakshya 2027, an exclusive batch designed only for serious ISS aspirants.